So let's talk about what we mean when we say that there's a circuit, okay, an electrical circuit. Now, circuit is a general word for any time that you're doing a routine, okay, or you've got something that starts somewhere and does some stuff and then ends up back where it started. So like maybe some of you guys do weightlifting, okay? If you do weightlifting, you might go to the gym and you have a circuit. And so you start and you're doing this, and then you're doing this, and then you're doing this, and anyway, and you have this routine that you do, and so you're going from one thing to the next, and that's, you would call that a circuit, okay? So let's talk about this thing here as a circuit, this artificial stream, okay? So I had some friends one time who decided they wanted to have a creek in their yard, and so they built a little waterfall thing in their yard, and basically they built a contraption that had a pool down here and a little pool up here. And then the water would kind of spill, make fun, bubbly creek sounds and whatever, rocks and plants and all that. And then they connected it out the bottom pool to the top pool, and they had a pump. Okay. And the job of the pump is exactly what it looks like. So it takes the water from below and it has to put it back up on the top. Okay. Now, this is a really important idea or model to keep in mind. Okay. So several things to illustrate here. All right. First of all, this is what we would call we would have to call this, if it's circulating, we would call it a closed circulation. Okay. Now, of course, there's going to be some evaporation in real life, but let's pretend there's no evaporation right now. So all the water that's in the system is the only water that's in the system. Okay. So this is a closed circuit as opposed to an open circuit, which would be if something somehow came along and snapped a water line there, and then our water is going to pour out. And the pump won't have anything to do. Okay. So if an electrical circuit is closed, that means current is flowing. Okay. On the other hand, if it is an open circuit, that means current cannot flow. All right. So for some of you, that might seem a little backwards of what you would normally think, but a closed circuit is one that's operating. Okay. Another important idea here is that in order for the pump to work, there has to be water in the system already. Now, in the case of an electrical circuit, all right, we're not moving water around, but we are moving around electrons. And those electrons already exist inside our circuit, whatever that happens to be. So as soon as our electrical pump begins to operate, then all the electrons are moving all at the same time. Just like in our system here, it's already filled with water. There's water everywhere. As soon as we start the pump running, then water is going to start to flow immediately. Okay. So we are filled with electrons. All right. They're already there. The pump doesn't introduce new electrons to the situation. Okay. All right. The other thing we want to focus on here is that what the pump does for us is it puts in energy. All right. So in this case here, we're actually putting in, it's mechanical energy that turns into gravitational potential energy. All right. So we've got a delta U in this case. So we're putting some energy into it. And as all the water moves along here, then that potential energy gets converted into kinetic energy. So we've got a height change turning into a speed change. All right. And it takes a constant amount of input to do that. Okay. Because this is what we would call a non-conservative system. All right. As soon as we turn the pump off, it all stops. Okay. It doesn't just keep going all by itself. Okay. All right. So if we think about, a system like a flashlight here, all right, then what happens is the electrons are going to go out. They're going to follow the metal, come back through, and then pop back in on this side, okay? And so from the point of view of the electrons, all right, this is the uphill side, and this is the downhill side. And the battery is our pump. So the battery is pumping those electrons, all right? So those electrons are already there, all right? So we're already full of electrons. They exist in all the metal, okay? This happens to be a closed circuit if the light is on. If we flip the switch, then it becomes an open circuit. And much like our water pump, then there's no way, you know, if we have a break in the line, there's no way for the water to get through. If we have a break in the line here, there's no way for the electrons to get through. Okay. And then the third thing is that energy is being added to the electrons by the pump, in which this case are chemical batteries. Okay. Now, a little thing we got to point out is that conventionally speaking, we usually talk about current flowing this way. Okay. That's what we call conventional current. And conventional current utilizes imaginary positive charge. And for that imaginary positive charge, then the plus is the uphill side and the negative is the downhill side. All right. And so we're adding energy in this direction here. Okay. That's Benjamin Franklin's fault, and I don't want to go into the history of it now, but he basically thought that there was positive electrical fluid and negative electrical fluid. Okay. And he didn't get it quite right. Okay. And today what we know is that if you have something with a positive charge, okay, what that actually means is that you are missing some electrons. And if you have a negative charge, then you actually have extra electrons. Okay, just like that. So just kind of think back to your basic chemistry. If you got a sodium and a chlorine atom, okay, they're both in balance. They have equal numbers of protons and electrons, so they're both neutral. However, if you bring these guys close enough together, the chlorine will just out and out steal an electron off of the sodium. Now, it becomes negative. It's got too many electrons, and the sodium becomes positive because it doesn't have enough electrons. Okay, so it's just some basic chemistry, just like that. Okay. Now, with our waterfall feature, we have a mechanical pump, all right, that can serve as a way to keep the water moving in the circuit. For a electrical circuit, we've got different kinds of pumps, all right, and these are not actually called pumps. They're called EMFs, all right, and that stands for electromotive force. And that's like a super generic term. All it means, the EMF means it's a thing that is able to get the electrons to start circulating. Okay. That's all it does for us. Okay. And there's different kinds. All right. So we might have a battery, for example. Okay. Let's take a look at this. So a chemical battery, all right, more accurately called, it could be a single cell. It could be multiple cells. If it's a single cell, it probably has like 1.5 volts. So like a AAA, AA, a C, a D type battery. Those are all single cells. If you have a 9-volt battery, that's actually 6 single volt cells. Okay. So that's a true battery in the sense that a battery is a collection of cells. Okay. Technically speaking, but usually we just say a battery when we're referring to anything that we can plug in and get to do something fun. Okay. Now, the way a chemical cell works, a chemical EMF, is through the same mechanism with the chlorine and the sodium. Okay. And so basically it has to do with the atomic structure of each one of these. Okay, so we are going to have, for example, in this battery here, all right, we may have a casing, okay, some metal here just inside of it that's made out of zinc. Okay, and that's made out of zinc, and then attached, or then within that, we're going to have a rod, which is probably made out of carbon. Okay, zinc and carbon. All right, and then in between here, we have to have some kind of an acid. Okay, we need a fluid or something that allows our electrons to move relatively well. Okay, and the carbon and the zinc are kind of like the chlorine and the sodium. So if we bring our carbon and our zinc close together, electrons are going to automatically want to jump across there. Okay, so what the acid does is it provides a way for the electrons to jump from one side to the other. Okay, and there's a chemical reaction that happens when that occurs, and it's that chemical reaction which causes then this to become positive. Electrons want to come over there, and they want to get away from this end over here. So that's our pumping action. It's the result of chemical action, which is the result of electronegativity differences, which are the result of electron affinities of different molecules. Okay? Hopefully all that makes sense. Now, when the battery's running, okay, there's a little coating that begins to form all along both sides, both the zinc and the carbon side, okay, because it's a chemical reaction. And a little bit of crusty, yucky stuff builds up in there, and then that makes further chemical action harder to take place. So the rate of the chemical reaction begins to slow down. So over time, what typically happens to a battery is its voltage won't change very much. And I'm going to talk about what voltage means later in the lesson. But its voltage won't change very much, but its ability to produce current, okay, in other words, how much stuff is flowing, all right, really begins to go downhill. Kind of think of this like you've got your pump and you've got pipes, all right, and maybe they're like really old iron pipes, okay, and old iron pipes, they'll get this calcium buildup inside, limestone buildup inside of them from the water. So over time, the metal pipes get narrower and narrower. That's kind of like the same sort of thing. All right, the pumping power is still the same. However, the hole is smaller, so the pump has a harder time getting the water through there. With the case of the battery, you've got the same chemistry there. All right, however, moving the electrons itself becomes harder and harder because it's harder, because you've got corrosion on the inside of this battery, okay? The battery is not a container full of charge, all right? It's just a pump, and eventually the pump wears out. Other EMF sources, all right? So solar cells, okay? So it's a kind of device. When light hits it, it can cause current to begin to move, okay? And then just, regular old generators, and there's lots of different kinds of generators. They all come back to having some wires and some magnets, and you turn the loops of wires in around the magnets, and that's going to cause electricity to flow. And that's a topic that we'll hit. We'll explain that sort of in the second half of this module. Okay. Alrighty. So there we go. I don't want this particular video to get too long. There's just a few review questions for you in the soft chalk.